At its farthest point, the moon is 252,088 miles from Earth. That's a distance so vast that you could fit every planet in our solar system between them. Now imagine being stranded nearly that far out in space, watching your precious oxygen leak into the void, knowing you have just hours of breathable air left. The temperature is plummeting below freezing, your power is failing, and the only thing between you and the infinite darkness is a spacecraft with walls as thin as 3 layers of aluminum foil. This wasn't science fiction, this wasn't a Hollywood movie, this was Apollo 13. April 11th, 1970. As dawn broke over Florida's Kennedy Space Center, 3 men prepared to embark on humanity's 3rd mission to land on the moon. The space race was at its peak. The Soviet Union and United States were locked in a Cold War battle for technological supremacy, and NASA was about to launch its 3rd moon landing mission in less than a year. But this mission would become something entirely different. It would transform from a story of exploration into one of survival, pushing human ingenuity to its absolute limits, and demonstrating what people can achieve when failure is not an option. At Launch Pad 39, stood a Saturn V rocket, the most powerful machine ever built by humans. At its top sat 3 men, each carrying their own stories and dreams to space. Commander James Lovell was already a space veteran, having orbited the moon on Apollo 8. A former Navy test pilot and father of 4, this was supposed to be his moment to finally walk on the lunar surface. At 42, he was one of NASA's most experienced astronauts. Command Module pilot Jack Swigert wasn't even supposed to be on this mission. Just 72 hours before launch, he replaced Ken Mattingly, who had been exposed to German measles. Swigert had never been to space before, and now he was thrust into one of NASA's most complex missions with barely time to adjust. Lunar Module pilot Fred Hayes, a 35-year-old rookie astronaut, left behind his wife and 3 children for his first space mission. An Oklahoma native who worked his way up from newspaper delivery boy to test pilot, he had dreamed of this moment his entire life. At 2:13 p.m. Eastern Time, the Saturn V's 5 massive F1 engines ignited, creating 7.5 million pounds of thrust. As the rocket cleared the tower, few people watching suspected they were witnessing the beginning of what would become NASA's most dramatic mission. The launch was perfect. The Earth dropped away below them as they accelerated to 17,500 miles per hour. In just 12 minutes, they were in orbit. Even the loss of a second-stage engine, an issue that briefly worried mission control, was overcome by burning the remaining engines longer. The next step was crucial: the transposition maneuver. The command module had to separate from the last stage of the Saturn V, turn around, and dock with the lunar module that would carry Lovell and Hayes to the moon's surface. It was a delicate dance in space that they executed flawlessly. For the next 2 days, life aboard Apollo 13 was routine. So routine, in fact, that American television networks didn't even bother broadcasting their transmissions from space. The public had become almost blasé about moon missions. After all, NASA had already landed twice on the lunar surface, but 200,000 miles from Earth, in the cold void of space, a disaster was brewing. Inside Oxygen Tank 2 in the service module, damaged wiring sat dangerously close to the super-cold liquid oxygen. The tank had actually been damaged during installation, then subjected to improper testing that had pushed its heating elements beyond their design limits. Nobody knew it yet, but this combination would prove catastrophic. At 55 hours and 55 minutes into the mission, Mission Control requested a routine stirring of the oxygen tanks. The crew had just finished a television broadcast where Fred Hayes had playfully shown viewers how they lived in space. The mood was light. Jack Swigert flipped the switch to activate the stirring fans. "Houston, we've had a problem." Those 5 words, spoken calmly by Jim Lovell, would initiate a 4-day battle for survival that would captivate the world and push the limits of human problem-solving to their absolute maximum. In the first moments after the explosion, confusion reigned. Warning lights blazed across the control panel. 2 of the 3 fuel cells, which provided electrical power to the spacecraft, were dying. The pressure in Oxygen Tank 2 read 0, and Tank 1's pressure was falling rapidly. Looking out the window, Lovell saw something that made his heart sink: a cloud of debris and gas trailing behind the spacecraft. Their precious oxygen was venting into space. Within 3 hours, the crew would lose all power in the service module. The command module would soon be dead, with only limited battery power meant for re-entry. They were now in a crippled spacecraft, bleeding oxygen, losing power, and still on a trajectory that would take them around the moon and into deep space. In Houston, Flight Director Gene Kranz rapidly assembled his team. As the situation became clear, he delivered a message that would define the mission. Failure is not an option. The first critical decision was made quickly: use the lunar module as a lifeboat. It had its own power, oxygen, and propulsion system. But it was designed to support 2 men for 2 days on the moon's surface, not 3 men for 4 days in space. Every system would be pushed far beyond its design limits. The crew scrambled into the lunar module, which they had nicknamed Aquarius. The spacecraft was so cramped that one person could barely move without bumping into the others. Its walls were incredibly thin. The slightest puncture could mean instant death. Now began one of the greatest technical challenges in spaceflight history. The trajectory had to be changed. They were still on a course that would miss Earth completely. Using the lunar module's descent engine, something it was never designed for, they would have to execute a precise burn to swing around the moon and return to Earth. For 35 seconds, Lovell and Hayes manually controlled the burn while Swigert watched their trajectory. The slightest error could send them off course by thousands of miles. There was no room for mistakes, but their problems were multiplying. The carbon dioxide levels were rising dangerously. The lunar module had filters, but they were running out. The command module had plenty of filters, but they were the wrong shape, square instead of round. They wouldn't fit the lunar module's systems. In one of the mission's most famous moments, engineers on the ground had to devise a way for the crew to adapt the square filters using only materials available on board: plastic bags, cardboard from flight manuals, and duct tape. They called it the mailbox. It wasn't pretty, but it worked, scrubbing the deadly carbon dioxide from their air. To conserve power, nearly every system had to be shut down. The temperature inside the spacecraft plummeted to 38 degrees Fahrenheit. Condensation formed everywhere, creating a cold, clammy environment. Sleep was nearly impossible. Fred Hayes developed a painful urinary tract infection and ran a fever of 104 degrees. His crewmates had to huddle around him for warmth. Water became precious. The crew had to ration themselves to just a few ounces per day, about a sixth of their normal intake. They became dehydrated, exhausted, and cold, but they kept working, kept problem-solving, kept pushing forward. As they approached Earth, the greatest challenge still lay ahead: re-entry. They would have to power up their frozen command module, something it was never designed to do. The moisture inside could short out the electronics. The batteries might be frozen. The heat shield might have been damaged by the initial explosion. Following a meticulously planned sequence developed by Mission Control, they began powering up the command module. Each switch throw could potentially reveal a fatal problem. But system by system, the spacecraft came back to life. Then came the moment of truth. They had to separate from their faithful lifeboat, Aquarius, and the damaged service module. When they finally saw the service module drift away, they were shocked by the damage. An entire panel had been blown out by the explosion. The heat shield could easily have been compromised. Re-entry began. The capsule hit the atmosphere at 25,000 miles per hour. Outside, temperatures reached 5,000 degrees Fahrenheit. For 4 agonizing minutes, longer than normal, Mission Control lost contact with the spacecraft.
Odyssey Houston, standing by, over.
Okay, go.
Okay, we read you, Jack.
Its voice crackled through the static. They were alive. At 12:07 p.m. on April 17, 1970, Apollo 13 splashed down in the Pacific Ocean. After traveling 622,268 miles through space, they landed just 3.5 miles from the recovery ship USS Iwo Jima. In failing to reach the moon, Apollo 13 achieved something perhaps even more significant. It showed humanity at its best. People working together, solving impossible problems, refusing to accept failure. The mission demonstrated that even in the darkest moments, 200,000 miles from home, the human spirit can find a way to survive. Today, the command module sits in the Kansas Cosmosphere and Space Center. Its scarred exterior tells the story of those harrowing days in space, but the real legacy of Apollo 13 lives on in the lesson it taught us. With enough determination, ingenuity, and teamwork, even the most hopeless situation can be overcome. Commander Jim Lovell would later call Apollo 13 NASA's successful failure. While they never reached their intended destination, they achieved something far greater. They showed us what humans are capable of when failure is not an option.